So what I want to do right now is just talk a little bit about parts of trees, and this will fall into our evidence that we can use for reconstructing fire. But first of all, so this is an oak cross-section. It was a dead tree at the time we cut it. This is actually a gamble oak, Quercus gambellii, if anybody knows gamble oak, which is probably about the oldest and biggest oak I have sampled in Colorado. This is from down in southwestern Colorado. 330 years old, just to get that off. But all I want to do on this one is just show you some different parts of the tree. So first of all, most of the tree is xylem. Wood is xylem. We'll have that in lecture as well. Hardwood and sapwood is the two things I wanted to show you here. Most of this is heartwood, all of the brown area. Oak is a really good one to show hardwood-sapwood differentiation because there's such a strong contrast. Hardwood is non-functional xylem. It's all plugged up with basically the extractives, waste products from respiration in the tree. The sapwood is the functional xylem, the white band right there. Sapwood is actually where water and nutrients are being pulled from the soil, traveling up the stem all the way out to the leaves. We'll talk more about that. And then the final thing I just wanted to point out on this one is the bark. Bark is actually pretty critical for our discussions of adaptations to fire, because bark thickness is really important as to whether or not the growing tissue, the cambium, is protected enough from the heat pulse caused by fire. It does not take much to kill that cambium. About 140 degrees Fahrenheit for about a minute is all. About the same amount of time it takes to cause a third-degree burn on us. So that cambium is very sensitive to fire. You kill that cambium, you've killed the tree.